Okay, joining us next is Piotr Gryko from Poland, presenting anonymization of sensitive information in financial documents.
So my name is Piotr. So as the announcer introduced, I'll be talking about how to remove sensitive information from financial documents and indeed any document. So the goal is, if you're working with financial documents or medical documents, there are rules about how long you can keep the documents before you have to delete them. However, the documents often have useful bits of information we might want to keep for training more sophisticated machine learning models. So for example, this bank statement, it's got identifiable information because of the name, the address, but we will want to keep something like the tables here and here to pass into more sophisticated machine learning models for later retraining. The key thing is that you want to eventually build up a large data set of high quality data, which you can build more sophisticated machine learning models. And you can't do that unless you've removed the personal identifiable information. So there's a talk by Eric Schmidt from a couple of years ago where he tries to predict what the next $100 billion company will be. In his opinion, he actually makes a strong argument that it's not the AI models themselves which will make the companies valuable, but the actual data that they have that they use to train these models, especially if the data is specific and niche. So medical data, financial data, things that you can't just scrape off the internet. So the key techniques behind this. So the first stage is you have to identify what is the sensitive information, and you use a technique called named entity recognition. Then the next step is, once you've identified, to either mask it or replace it with a synthetic replacement. Finally, you want to use a technique to try and fix the document so it looks similar to what the original document looked like. So I want you to have a look at sort of this this map, essentially, of Europe. So I asked ChatGPT to generate a picture of Europe. And at first glance, it looks actually pretty reasonable until you kind of look into the fine details. And then it's basically fairly deceptive. So I want to get across is that a lot of machine learning now is just plug it into ChatGPT and use that by de facto. And you can do a lot of stuff, but it'll often basically do things like this. It will give you an answer which looks reasonable, but it'll start to basically hallucinate and do weird things. So you can get a lot of things done by actually taking specialized models, fine-tuning them. Don't rely just on ChatGPT. So in terms of identifying sensitive information in documents, the technique is named entity recognition. There are lots of techniques on this, starting from simple to more advanced. So simple regex, they'll pick up things like IBANs quite happily, or standardized bank account numbers. Things such as like addresses, people's names, those kind of things become more complicated. SPACY does actually a pretty decent job. And then that's the idea. You tend to go from simple to more advanced. My strong recommendation is you start off with a base model and you keep that before going to more advanced. And I strongly recommend using SPACY for that. It's battle tested, it has tooling, off-the-shelf tooling, and it's easily trainable as well. Now, regex, SPACY, and layout LLM version 1, they all require a base OCR layer. Now, so that means you have to OCR your document, and then you extract text and positional information. The problem with that is what happens if you've got a document which is slightly damaged or malformed. So you have a bank account number, but the last 3 digits are cut off, for example. Something like regex and SPACY might struggle with that. Other techniques which don't rely directly on OCR do a little bit better, but because they're more sophisticated techniques, there's more risk of hallucination, and they can often do weird things. That's why it's so important to have a baseline tool in my recommendation, spaCy, which you can then basically contrast and compare more complicated tooling. It should be said you can do more than one. You can use more than one tool at the same time on your document. When you're removing personal information, the worst thing you want to do is let personal information slip through your system. If you over-anonymize and actually replace things which aren't sensitive, that's not the worst case. So now you've figured out what you actually want to anonymize and remove. You can operate like the CIA and just black things out. But the problem is if you feed this down into your further downstream machine learning models, you've damaged the original document and you've introduced a strong contrasting feature. The risk is basically that the other machine learning models might start to learn basically the damage you've done to the document as a feature. You can, of course, because this document is simple, you can, of course, replace it with just a sample font on a white background, but that also has the limitation that it won't work with backgrounds which are more complicated. So the common approach to this is to use diffusion models. Diffusion models are basically trained by introducing Gaussian noise to the images, and then the model learns to denoise it. The naive approach is to just use something like Stable Diffusion 2 and to use its inpainting method, which is what Photoshop does, to try and inpaint text. As you can see up there, this doesn't work very well. And it doesn't work well for a couple of reasons. Firstly, Stable Diffusion is mostly trained on natural images, so trees, cats, dogs, that kind of stuff. Text documents have very sharp boundaries, such as because of text, and it's not represented in the underlying data set. Secondly is an issue with the actual sort of positioning. As you can see here, I wanted it to replace Adam Jensen, and it did a decent job trying to replace things, but it also went just below the actual boundary condition and replaced the address down here, which I didn't want. I mean, this makes sense if you're altering natural images because you want to make the surrounding area sort of consistent, but it's not something you want with with financial documents. So there's a number of different papers that try to do inpainting on text. The one that we found that worked actually quite well was a paper called diffu. This paper does it's based off Stable Diffusion 1, and it does a couple of very clever tricks to make the inpainting work. So I'll just explain how Stable Diffusion 1 approximately works. There's three main components. So there's the UNet, which is the underlying diffusion process, i.e. tries to correct the image and is trained on correcting Gaussian noise. Because this is computationally expensive, a computational hack is to use a variational autoencoder to basically take the underlying image, convert it to something called a latent space, which is just a matrix which has got small dimensions, and then be able to convert it back to an image. The third component is something called clip. So this is used as part of the conditioning step, so that you can basically pass in via an embedding model context to the UNet, so that so you can tell it to basically generate it generates something based of text or of existing images. So what the diffu paper does is it makes two main changes. First, it replaces clip with TR-OCR. So this is a pre-trained recognition model, and they hook the embedding straight into the UNet. Secondly, they retrain both the variational autoencoder, so this, and the UNet. So the training step is done first with the variational autoencoder, and then the UNet. The reason you have to retrain the variational autoencoder is because it essentially converts an image to latent space and back again. And it doesn't do well on text because it was trained on natural images. So you have to retrain this first. After that, you fix the UNet. You fix the variational autoencoder. You also fix the OCR, and you retrain the UNet. The paper itself does it in the following way. So it identifies a little bit of text that you want to mask. In this case, I've chosen a name that was on the document, Adam Jensen. It generates 3 separate images. So a masked image, and it takes the original image and adds noise to it. It then basically encodes each of these through the variational autoencoder into latent space, concatenates the images in latent space, then passes them to the UNet. Then to the UNet via TOCR, an embedding is passed of the original text, just an Arial font of the image is passed in, and then the UNet essentially is trained to try and reconstruct the original image. So that's your training loop. Now, there's the other trick that the paper does is that it adds a form of self-supervised learning to this. So you basically have to select a bit of text that you want to mask out and train, but it doesn't have to be personally identifiable information. You actually use any bit of text across the document. So what you do is you pick one bit of text here, you run your training across that. Next bit of text here, and again, next bit of text there. So it allows you to basically to add a lot more training data to your existing training pipeline. The original diffu paper was trained, I think, on 5 million documents. When we reproduced it, we trained on about 1 million documents. So this technique was really powerful because it allows you to basically focus the model on doing exactly what you want to do on a limited data set. So for the inference stage, the inference is just like training, with the one difference is that instead of using the original text, you add in a new text via the embedding. So these are the actual results. The results work reasonably well for simple documents, but honestly, I could probably do better with Photoshop. So the font here is a little bit darker than the original up here. And there's also a shift between like the actual person's name and the address. It's not done too badly here. It hasn't modified any of the actual tables, which is the important thing. And that if we want to keep this data essentially for training later, to build a large corpus of high quality training data, this is actually fairly decent. Now, where this actually really shines is more complicated documents. So here I've taken a sample identity card and replaced the person's name, date of birth. And this model handled fantastically the actual background. So I picked an identity card not because it's actually useful. Everything in an identity card is personal information, so it makes no sense to actually de-anonymize it. But it was useful because it has a complicated background, and the model did really nicely with the backgrounds here and here. And I think it actually did a better job than I could do using Photoshop. Obviously, it didn't handle the actual person's face because the model wasn't specialized for this. Personally, what I would do is I'd build another model specialized just for the embedding of the faces. But like I said, it's not useful to de-anonymize identity documents. But I just wanted to demonstrate that this process is extremely powerful for complex documents. Now, in terms of the limitations of the edits, so the edits don't work on high net worth individual. If you're worth $100 million and you live in Vilnius and you provide a bank statement, people can probably figure out who you are, even if you remove the names and the dates. Also, you've got unique titles. If you're a lord or a king, those kind of things just don't work. You're too unique. Secondly, if you're doing edits, you have to be consistent with the name across a document, approximate gender or title. Also, if your documents are complicated and contain very specific niche things such as if you're doing mortgage documents or things about a person's history, even if you remove the person, there might be enough information within those documents to de-anonymize a person just using Google, just based on raw context. So those are tricky edge cases, and you have to bear those in mind. So to summarize, I've actually done this presentation faster than I expected, but I'll go over what I wanted to get across. So high quality data is the new oil, essentially. And it's important to build a high quality corpus of data if you want to train high quality machine learning models. If you work with sensitive information, so financial documents, medical documents, you can't keep them for very long. So being able to remove personal identifiable information from them is really, really useful. The keys to it is using named entity recognition. Out of named entity recognition, start with a baseline model, and then use more advanced models for identifying the information. Then use diffusion models to fix up your documents. We used diffu, that worked pretty well for us. And I think that kind of brings us to a close. So I want to thank the organizers of PyCon Lithuania. It's really hard organizing a conference like this. It's a lot of work, it's exhausting. Thank you for inviting me. And my details are up here. So I live in Warsaw. If you're in Warsaw, drop me a line on LinkedIn. I run a meetup in Warsaw called AI Code and Coffee, so you're also welcome to join us. Finally, there's a defense hackathon running in May here in Vilnius. It coincides with the some kind of Baltic defense conference as well. I went to the defense conference in Warsaw 2 weeks ago, sorry, the defense hackathon 2 weeks ago. It was really high quality. I highly recommend it if you're interested in moving to the defense space. And that's it from my end.
Do we have any questions?
So what about the document such as a mortgage? What would you do with it?
So when you apply for a mortgage, the bank has to do compliance, right? So the idea is it's not just a mortgage document, but it's a collection of documents. So it's usually a pension certificate, the mortgage document itself, whether you're divorced or not, because they take that into account in terms of, I think the term is alimony, essentially, whether you're paying for your other partner. So you want to remove basically name, identity, possibly skew the dates as well. Anything that's kind of sensitive in that regard.
Right, thank you.
Hi, Piotr. Thanks for your talk. I remember on LinkedIn recently you were correcting someone who was doing some bad quality Photoshop, and you were mentioning how in identity documents, your method can retain the Fourier space features or the additional cybersecurity forensic things. So you're basically doing deepfakes on identity documents, and you're possibly able to fake realistically and pass those filters. So I'm wondering, when you are doing these, of course you're doing it in-house and you're not, breaking the law or anything, but do you have any applications where you would use LLMs to decide what to take out? So how do you make the decisions for what to change and what to fix? Is it just scripted rules for the workflow, or do you have any LLM or agentic decision making on what data to change and how to change the data?
So it sounds like there's a couple of questions in that. So firstly, it's sort of not my work. So I based it off the diffu, right? So I have to basically sort of contribute the original authors. So they produced the paper and code. So I want to give full credit to them. I based my work. Well, we based our work off their work essentially. the second question is in terms of that LinkedIn post. Like I'm surprised something from LinkedIn found me here, but I'm glad I'm getting some kind of reputation. So for the rest of the audience who wants a bit of context, there's, I think, a company out there who's trying to sell their own services in terms of providing identity, and they were basically throwing out bad Photoshop, using Photoshop to basically bad versions of ChatGPT to Photoshop things. So I posted just that a lot of the images that are generated using either ChatGPT or diffusion models, if you transform them to the Fourier domain, that the images look different compared to natural images. And that's one way of detecting essentially AI-generated content. It's not foolproof because technically, if you go back to the actual training loop here, we could try adding in essentially a Fourier constraint in here as part of it, so when it actually denoises it, it also is forced conditionally there. So it's not foolproof in that. In terms of using an agentic workflow, I mean, agents are definitely fashionable. I'm not sure sort of like in terms of how you would apply it to this essentially. So agents tend to be used in terms of creating workflows, right? And dynamic workflows, so things that change all the time. In terms of choosing what to in terms of anonymization, personal identifiable information is quite a strict list already. So you just operate off that. Definitely, it's useful to use when you say LLMs. I take VLMs, like visual language models, and those are definitely useful to put a pass-through through your data. It should be noted that in terms of stuff I've demoed, all of this you can do locally, essentially. That if you're working with financial documents, you should be able to basically host all these models locally, or use a provider which hosts them locally, and that includes some more powerful visual language models. So I know Minstrel, I think, allows theirs to be enterprise on-site hosted, and I think Google said their Gemini model, they're also going to offer that. Did that answer the question, or?
All right. We also have one question from Discord. Why do you still need to anonymize physical images instead of leaving only text information and anonymizing that text data then?
Because we want the original images. That's the whole point. So let's go back to the original document here, right? So when you work with PDFs, you don't trust the PDF full stop. Like everything in terms of financing to work of PDF, if you're applying for a mortgage, or if your doctor's sending something through, everything is basically scanned and saved as a PDF. PDFs you don't trust because they're an ancient format and you can pump garbage into them. So what you do is you convert the PDFs into images, and then you operate purely off the images, and everything in your pipelines go off that. The OCR, extraction, all of that. So you want to keep the original images because at some point you might want to fine-tune models or more sophisticated models to do extraction of the table data here or here, right? So then when the banks basically start to make financial decisions, initially it's compliance, saying, okay, we have bank statements to confirm this person has an income, but 6 months down the line, we want to have models which we have fairly good control of, and we know we'll extract this information and this information. And the only way we can do that is we have a large corpus of data, which is image data. It's image data based off the original documents, but doesn't have this personable, identifiable information in it. I'm hoping that answers the question.
All right. Thank you. If you have any more questions, you can leave them at the Discord or talk directly to Piotr. Thank you.